Hello, welcome all. This is Dr.G.P.Halde. I'm Assistant Professor in the Department of Electronics and Communication of Priyadarshini College of Engineering, Nagpur. Today I am going to introduce you in brief about the timers in 8051 microcontroller. First of all, let us understand what are the timers or counters and what are their roles in the 8051 or in any microcontroller. Timers are used to measure the time and for creating the time delays. Similarly, the counters are used to count the events or tasks that are taking place outside the microcontrollers. The same timer register can also be used as a counter. It can function as a timer as well as it can function as a counter. Whenever the external source is driving the timer register, it is acting as a counter, and when the timer operates on the internal clock, it is acting as a or it is functioning as a timer. So for 8051 microcontroller, there are two timers or counters, timer 0 and timer 1. Each of these timers is of 16-bit, that means it can load the maximum 16-bit value and which is equal to FFFFH. Now let us understand the structure of the timer or counter available in 8051. Each 16-bit counter of the 8051 is divided into two parts and each part is of 8-bit. So accordingly for timer 0, it is divided into TL0 and TH0. TL0 stores the lower byte of the count value, whereas the TH0 stores the higher byte of the count value. And same is for the timer 1. The timer 1 is divided as TL1 and TH1. The TN1 will store the lower byte of the count value and TH1 will store the higher byte of the count value. Now let us simply understand how the timers function to generate a desired delay in 8051 microcontroller. Let us say for example, we have to generate a delay of 1 millisecond using the timer 1 of the microcontroller 8051, and the 8051 is operating at a frequency of 12 megahertz frequency. So the frequency of operation for the controller is 12 megahertz. The controller is designed such that the external frequency or oscillator frequency of the controller is internally divided by 12 and that frequency is given to the counter for operation. So thus if the controller is operating on the 12 megahertz, it is divided by 12 and therefore the actual frequency given to the timer operation or counter operation is 1 megahertz. According to the 1 megahertz frequency, the time period for this timer or counter will be therefore 1 microseconds. That is 1 upon 12, it becomes equals to 1 microsecond. Now the problem given to us is to generate a delay of 1 milliseconds. Now to generate a 1 milliseconds, 1000 into 1 microsecond clock pulses have to be counted. That means if 1 microsecond clock pulses are repeated 1000 times, then the delay produced or delay generated will be of 1 milliseconds. Okay. So therefore, we have to count the 1000 clock cycles to generate a delay of 1 milliseconds. So according to now, we will have to calculate the count value that has to be loaded into the TL and TH register of the desired timer or counter. So the maximum limit or maximum capacity of each timer register is of 16-bit. So the highest count that can be loaded into that register is FFFF in hexadecimal. Now we have to count the 1000 clock cycles. So this 1000 decimal value is also converted into hexadecimal and which comes out to be equals to 03E8 hexadecimal H. Now this value is subtracted from the final count value. This is because whenever the timer or counter operates, it starts from the value which is loaded into it and it finally reaches to the terminal count value, and the terminal count value is nothing but that FFFFH. So therefore, for that reason, we are first subtracting this 03E8 hexadecimal value, which is the equivalent, hexadecimal equivalent of the 1000 clock cycles. So it comes out to be FC17H, and now 1 is added to that. So final count value which is to be loaded into the timer is FC18 hexadecimal H. Okay. So FC18H will be the count value which is to be loaded into the T0 timer register or T1 timer register, and therefore TL1 will have 18H and TH1 will have FCH. Since we are using timer 1, if we are using timer 0, then it will be TL0 equals to 18H and TH0 equals to FCH. Now for programming the timer, certain other registers are used. So let us study in short about the programming model for the timer. There are three important registers to use the timers of 8051 microcontroller to generate a delay. The first register we have already seen, that is the T0 or T1 register, in which the count value is to be loaded. The second important register is called as the timer mode register, also known as the T-mode register. This timer mode register is used to select the mode of operation of the timer 0 or timer 1. Basically, timer 0 or 1 operates in 4 different modes: mode 0, mode 1, mode 2 and mode 3. According to the requirement of the delay generation, we can use any of these modes of operation of the timer. So here it is gate pulse is there. Gate pulse is used as a gate to start the timer operation. C/T1 or C/T0, this bit indicates, or this bit decides whether the timer register or counter register is working in a counter operation mode or a timer operation mode. And then last two bits like T1M1 and T1M0, these two bits decides the modes of operation of the timer 1, and similarly T0M1 and T0M0, these two bits decides the mode of operation for timer 0. The next register is the timer control register. It is TCON, and this is used for controlling the timer operations. That is to turn the timer on or to stop the timer. The TCON has TF1, then TR1, TF0 and TR0. These are the basically 4 bits which are actually related to the timer operation. The TR1 and TR0 bits, these are called as the timer run bit 1 and timer run bit 0. That is the timer run bit for timer 1 and timer 0 respectively. Whenever this bit is set to 1, the timer starts counting from the counting value loaded into it, and then it counts till it reaches the final count value. Similarly, whenever the final count value is reached, the microcontroller automatically sets this TF1 or TF0. TF stands for timer flag 1 and TF0 stands for timer flag 0. So whenever it reaches the final count value, this TF1 is automatically set, and the 1 in this bit indicates that the timer operation is over, the final count value is reached, and therefore the delay may be generated. Desired delay is getting generated. Now for delay generation, for the example we are considering, that is for 1 milliseconds, we will have these bits or these registers configured. For T-mode register, the gate 1 or gate 0, this will be 0 because we are not using that mode of operation. The counter or timer operation, this will be set to 0. To use it as a timer operation, for timer operation, it works according to the internal clock pulses. Then T1M1 and T1M0 are set to 0, 1. That means T1M1 is 0 and T1M0 is 1. This indicates the mode 1 operation. Now mode 1 operation is 16-bit timer or counter. That means it will start counting the values from the value which is loaded into its registers, and it will reach to the final count value, that is FFFFH. Now accordingly, we have decided this configuration. So T-mode control word will become 0001 and 000 in binary, and so in hexadecimal it will be 10H. Now let us come to the TCON register, that is timer control register. This is we are using to run or stop the timer. So TR1 bit is set to 1 to run the timer, and whenever we want to stop the timer, we will reset this bit to 0. So now according to this, the final delay program will be delay move tmod comma hash 0001 and 000B. So that is the tmod register is loaded with this configured value so that the timer 1 is used in mode 1. Then move th0 comma 0 fch. So the count value was fc18h. So in the higher register of the timer 0 or timer 1, the value will be loaded as fc, and in the lower register the value will be loaded as 18h. Now the timer run bit is set, so set B TR0 will start the timer. Then next we are coming here JNB TF0 comma here. With this instruction, the microcontroller is continuously checking the timer flag bit to become equals to 1. Whenever it finds that timer flag bit has become equal to 1, it means that the timer has counted all the 1000 clock pulses and now it has set 1 to indicate that it has reached the final count. So till it is not reaching the final count, it will just loop in the same instruction that is here. The instruction says jump if no bit TF0. Unless and until the TF0 is 0, it will be just remain, or it will be looping on the same instruction, that is here instruction only. And once it becomes equals to 1, once the TF0 becomes equals to 1, it will come out of the loop and it may perform some another task or whatever is done as per your program. So I hope students you will have would have understand the basic operation and delay generation using 8051. Will come again for such small conceptual videos in the next parts. Thank you.